Hello. Hello and welcome to this video. In this video, we will continue with network address functions and operators. So this will be a slightly short video because there are only 4 pages and there will be no examples for this because the documentation provides quite clear examples for this particular section of the documentation. Now, I'll try to run as many as I can. So without further ado, let's get started. The IP network address types CIDR and INET support the usual comparison operators shown in table 9.1 as well as the specialized operators and functions shown in 9.39 and 9.40. Any CIDR value can be passed to INET implicitly. Therefore, the operators and functions shown below as operating on INET also work on CIDR values. Where there are separate functions for INET and CIDR, it is because the behavior should be different for the two cases. Also, it is permitted to cast an INET value to CIDR. When this is done, any bits to the right of the next mask are silently zeroed to create a valid CIDR value. So first we have less than operator, which operates on 2 INET, returns a boolean. So what it does is subnet strictly contained by subnet. This operator and the next 4 test for subnet inclusion. They consider only the network parts of the two addresses, ignoring any bits to the right of the net masks, and determine whether one network is identical to or a subnet of the other. So for example, if we select this, so we put this and we select and it should return true. Okay. Oh, sorry. I made a mistake. So we select here and we give single quote here. So it should have returned as true, right? There is something wrong here. Okay, I still have a single quote here. Okay, now it will work. Select this and we single quote this and we have true as a result. If you run other ones, it will return false and false. Then we have less than is equal to operator. So it tests whether subnet contained by or equal to subnet. So this will give us true. Then greater than, which is does subnet strictly contain subnet? And you see that this subnet contains this. Then we have greater than is equal to, and here both are equal. Then we have and does other subnet contain or equal to other? So this subnet, if you see, it is a 24-bit subnet, and it will definitely contain the 28-bit subnet. And this is our 24-bit subnet 192.168.1, while this is 2.2 series 192.168.2. So definitely .1 will not contain .2. Then we have tilde net, which computes bitwise not. So if you do this, you get another INET. Then we have ampersand, which computes the AND gate, bitwise AND gate for this. So you see there is something strange which you see here. It is, if you see both of these, then it is bitwise AND. So you have to be careful. It may fall in the range, it may not fall in the range. Okay, so you have to be very careful about what you're doing here. Then we have OR, which will compute the bitwise OR. Then we have plus begin, which adds an offset to the address. So if you add 25, it will add 6 to this. Now the interesting case, for example, I'll show you here. So suppose we put this here and we deliberately make it 255. So 255 plus 6 will be more than 255. Let's see. You see what it does, it overflows into the next subnet. That is, after 255, it increases this, okay? And then this is less than 1, it decreased by 1. Then we subtract and similar thing will happen. The result will be an INET, and INET minus INET will give you a begin, the difference between them. And now we have IP address functions. We have every function creates an abbreviated display format as text. The result is the same as INET output function producer. It is abbreviated only in comparison to the result of an explicit path to text, which for historical reasons will never suppress the netmask part. Then we abbreviate CIDR part, so creates an abbreviated display format as text. So these two are redundant here for this CIDR. For 16-bit subnet, 10.1 is significant, so that is your abbreviated version. Then you compute the broadcast address, which is typically 255 or the last IP address of the subnet. Then we have family. So family will give you either 4 or 6, 4 for IPv4, 6 for IPv6. Then we have host, which returns the IP address as text, ignoring the net mask. We have host mask, which takes an INET and gives an INET, which computes the host mask for networks addresses network. Then we have INET merge, which computes the smallest network that includes both the given networks. So if you see this, these are 224-bit net masks, and they will be covered in 22-bit. Then we have INET underscore same family. It checks whether the two INET addresses belong to either IPv4 or IPv6. If they belong to different ones, then it will return false. Then we have mask length, which will return the number of bits in the net mask. Then we have net mask computes the network mask for the addresses network. For example, this, it will compute the network mask. Then we have network INET, returns the network part of the address, zeroing out whatever is to the right of the net mask. This is equivalent to casting the value to CIDR. Then we have set mask length, INET comma integer. So if you give it an integer, it will set the net mask length for that INET value. Then we have set mask length, which takes a CIDR an integer, sets the net mask length for a CIDR value, address bits to the right of new net mask are set to 0. So it is 24-bit and we are converting it to 16-bit. So the last two octets are set to 0. Then we have text, which takes an INET and returns a text, which returns an abbreviated IP address and net mask length as text. The abbrev host and text function are primarily intended to offer alternative display formats for IP addresses. The MAC address type, MAC ADDR and MAC ADDR8 support the usual comparison operators shown in table 9.1 as well as specialized functions shown in 9.41. In addition, they support the bitwise logical operators tilde, and or, that is not and or, just as shown above for IP address. We have trunc, which sets the last 3 bytes of the address to 0. The remaining prefix can be associated with a particular manufacturer. So for example, you truncate this and last 3 bytes are 0. Then we have trunc MAC address 8, sets the last 5 bytes of the address to 0. Then we have MAC address 8 underscore set 7-bit, which takes the MAC address 8 and sets the 7th bit of address to 1, creating what is known as modified UI64 for inclusion in IPv6 address. And with this, we come to the end of network address functions and operators. And as you can see, tomorrow we will start text search functions and operators, which are going to be massively useful. Netmask functions are quite useful if you particularly deal with something related to networking. Then it becomes quite useful. All these functions and operators can be quite handy. Okay. So I'll end this video here and we'll meet again tomorrow with text search functions and operators. I hope that you're enjoying this playlist and learning more about PostgreSQL. Personally, I'm learning quite a bit, okay, while reading all the gory details of the PostgreSQL documentation and internals. So thanks a lot for watching the video and I'll see you tomorrow in the next one. Till then, I will take my leave and wish you a great day. Sayonara.